right? And then it changes to, depending on the location, in Texas it goes to a flashing yellow arrow. And then that means you can make the turn, but you have to yield. You have to yield to oncoming traffic. We've released the opposing traffic, right? That's not, so you can either have fully permissive, with no protected portion, protected permissive, or fully protected, which the phases are completely separate. That's at least in the North American signaling context. 35-mile-per-hour posted speed limit. They had recently reduced it, but they weren't quite getting the compliance they wanted on that. I'm sorry, that's about 50 kilometers per hour. And I work in kilometers, but we had to convert because I'm from Canada, but for this we had to do everything in miles per hour. And then, again, this is just looking in the other direction. It's very similar. You notice the signals, again, they're quite hard to see. They're kind of against the sky, and there's nothing to kind of help them stand out. So we say no backplates. This is looking on the side streets. We have one through lane in each direction, and then it widens out to have a left turn lane and a little narrow median. And there's some accesses. There's a convenience store and bus stops and stuff like that. And they post this at 30 miles per hour, which is just a touch under 50 kilometers. So they gave us the collision data from this site. And what happened is they had done some interventions already. They had reduced the speed limit. They introduced the protected permissive phasing, so it used to be completely permissive. And they did a few improvements to the pedestrian crossings. And then they said, we want you to diagnose it to see what's the level of residual risk and what additional recommendations and additional benefit we're going to gain from the reflective treatments offered by 3M. So we have data from two phases on the crash data. But if you look at a lot of the sample sizes, you know, we're dealing with 1s and 2s per year, or 0.5. The one exception where the sample size is clearly showing an issue is in the left turn across path, those yielding crashes. But everything else is quite statistically questionable from a sample size like this. And we look at the time of day of collisions, the contribution of red light running, and that a lot of these collisions are actually happening after dark, okay? So we use the 5 o'clock because in the winter it's getting dark earlier, right? So we want to talk a little bit about some of the key issues we found. So we found that the speeds along Pleasant Valley, that their strategy of reducing the speed limit hadn't worked. People had just kept driving the speed they were always going. And the road environment was giving them some speed cues that were inconsistent with the posted speed limit. So that influences, you know, rear-end collisions and high potential speeds, impact speeds. We found the left turn versus oncoming vehicle crashes continue to be a key issue. That it reduced from 40% of all collisions in 2012 to 2015 down to 20%. But there were still a lot of near misses, and this has not been effectively dealt with. So we recommended, you know, taking that a step further to go to fully protected phasing. And then there was a significant amount of red light running. Okay. So in addition to reporting conflicts, and Gernot shared some conflict data, we also can extract speed profiles. So we could just draw a gate across the video and say, how fast are the vehicles going? So we drew a gate and say for the southbound through, what's their distribution? And so we put them into different risk categories based on their speed. And you can take, you know, statistics like any traffic engineer would want, these kinds of statistics, 85th percentile and stuff like that. And you can see what percentage of that distribution is above the posted speed limit. That's a vertical kind of cutoff. Speed is on the horizontal axis, and the percentage of vehicles on the vertical here, if you're not familiar with histograms. Now, this is the near-miss conflict data. So along the bottom axis is every configuration. So the movements, the left turns, the through movements, they're reported in pairs. So this movement versus this movement, right? And so you can see immediately which configurations are popping out as risk factors and which don't really seem to be a problem. And then focus in on the treatment recommendations where there are a lot of near misses. Okay. And then a similar chart to the other intersection where you get, I'm just going to explain this data a little bit because he already explained the type of conflict. We provide a visualization, image and video clips, a temporal distribution. So the top right is temporal, so what hour of the day are these near misses happening? I'll go to the bottom right. That's a scatter plot of every event. He talked a bit about that one, how severe, the red severe and the orange. There's an online tool where you can click on that point because that represented an event, and you can watch a 10-second video of it occurring. We didn't have that at the time of this study, but that online clickable video is new. And this risk table, what that does is that shows not just the frequency, but if that happened in a few days, we do an annualized estimate. So we just take 365 divided by the number of days of the study and multiply that by the measured frequency to give the decision makers how many near misses are we going to let happen in the next year until we do something to fix it, right? Now we know we're kind of obligated to fix it. The conflict rate is the third. I don't know how big this is. And that says okay, out of everyone who made the southbound left, what percentage is in a high risk? So 1.77%. And then the last one, relative risk, it says how does that 1.77 compare to a benchmark? And here it's 1.58 times over the benchmark. So usually the percentage in a high risk would be lower than 1.77. You just divide it by 1.58, that's the benchmark. So they can find, sometimes there's limited resources, and someone says, well, if you change this to fully protected phasing, it's going to increase overall intersection delay, and we're not sure if we want to do that. But then when you tell them, okay, we're not recommending it where the risk is only half the benchmark. We've recommended it here because it's 1.6 times the benchmark, and it's a stronger justification for decision making. In the interest of saving time for questions, a lot of this data is just very similar for this intersection to the other one, but we ended up recommending a number of treatments, some signal phasing, like leading pedestrian intervals, fully protected left turns, and then also some of the reflective treatments, like improving the crosswalk visibility, the back plates, improving the signs. There's signs that ASTM type 11 sign sheeting, the brightest sheeting made by 3M, has almost twice as much visibility, light coming back from it as the lower levels. So we recommended enhancing that, and they're in the process. They've installed, the reason we haven't done this, I'm just going to go, this is all the vehicle pedestrian data, and we're getting close to question time, so I want to go to the pilot summary. They've installed about 75% of the things we recommended, and it's just, they just have some more coordination work. Some of the things they couldn't do because they were about to replace a water main under the street, so they didn't want to put all the beautiful new material on the pavement because in 4 months they were going to dig up the pavement and change the water main, right? So once that's done, we will do the after analysis, and we basically did 5 intersections, and a few of them are going ahead for the after analysis. One of them, they said, you know what, we actually need to completely reconstruct this intersection in 4 to 5 years, so we're going to wait and do all these improvements at that time. And then, I think even though we haven't done the before-after analysis, and I'm sure it's going to show a risk reduction from the reflective treatments and the other operational treatments, but they liked it. They said the value of the diagnostics is there, and so they they immediately contracted for 5 more intersections to do the diagnostics, and the improvement plans are in process. And then they told the state level Department of Transportation, and they've added it as like a standard purchasing thing they can just buy for their studies. And we've started up, 4 more through TxDOT, and that's going to be increasing because that approval just went in January. So I will stop there. We've kept about 10 minutes for Q&A, I will back up a bit, and Gernot and I will take the questions together.
Gentlemen,
I'm not used to like a catwalk, so that was an awkward kind of
I'm not using that catwalk, it's not for me. Anyway, gentlemen, thank you for that. Applause for Gernot and for Craig, that's fantastic. Thank you very much indeed. So, we have we have 10 minutes and 15 seconds for questions. So, whoever has a question, this is very bright here, put your hands up and I will come and talk to you and hand you a microphone. Who's got a question? I can't see anyone. Any questions? I can't see that, the lights are too bright.
There's one there.
There's one.
There's one straight ahead of you.
Oh, okay.
Yeah.
Got you, sorry. If you stood there, you literally can't see from there. Right.
We come closer. Yeah.
You could come, that'd be easy for everybody.
Anyway, for all the others, I mean, Craig has a booth. If you step out of here, you can't miss his booth for later discussion. And the same, if you just continue for 50 meters, you find the 3M booth, and I'm there. Well. So if any one of you later, tomorrow or Friday, has questions, wants to talk, well, you're welcome, of course.
Absolutely.
Hi, question for Craig. Hi. First of all, great presentation, just great. The Insurance Institute of Highway Safety released a report about 2 weeks ago about large vehicles and pedestrian right-turn collisions and risks. And we know that pedestrian fatalities go up mostly because of SUVs. I'm just curious to know mostly about your software, if it takes also momentum like vehicle size into account, not just their near misses, but perhaps near misses of if it's a large vehicle or a sedan or something like that.
Yeah, I want to talk about that specific issue, right turn versus near miss. I'm going to answer your question, but expand on it a bit. We currently classify road users into vehicle, motorcycle, cyclist, pedestrian, and e-scooter. So in any report we've done to date, we've not broken down the vehicle class, which is a weakness because a heavy vehicle will carry more kinetic energy and result in more force transfer to a road user, but we're not resolving that level of detail. But that vehicle class will be broken down into 9 subclasses: SUVs, pickup trucks, which are escalating in North America, large trucks, buses, vans. That machine learning model is going to be released in probably 2 to 3 months, and so our analytics going forward will break it out and adjust the severity based on the weight going in. But that specific type, the right turns is always an issue, and they're very amenable to treatment with reflective materials, right? So no right turn on red sign. To make that sign pop, you want to use type 11 sheeting. Or sometimes the speed of that turn is the impact of an old school geometric design which made a very wide radius. And let's say you don't have $200,000 to go and tear up and reconstruct the radius. You can actually just take some plastic poly posts and bolt them down into the pavement to do a kind of a temporary radius reduction. And on those poly posts, you definitely want 3M reflective sheeting on the top of them so that they really pop to the drivers and they can find their alignment through that. So we did some of that stuff on the right turn, like we call rapid build right turn improvements, for a few $1,000s, and you can do it in a week.
Like infrastructure improvement, change kind of the radius of vehicles turning and separate like the turn operation to where you would cyclists and pedestrians have crossing over. And then the visibility from any vehicle, but especially from larger vehicles, to the pedestrian or the bicycle would be much improved. So this is kind of the intervention or the infrastructure improvement that Craig is mentioning. I must say, for the sake of time, I cut it out of the presentation. We had some more examples in there this morning, but then when we combined our two talks, then we figured out we can't show everything, unfortunately. But thanks for the question.
Yeah, great. Thank you.
Excellent. Are there any more questions? Otherwise, you've got 10 more
6 minutes left.
I know, it's good. Anybody? No more questions. You were so comprehensive, everyone has learned everything. Perfect.
Thank you.
So, Gernot and Craig, thank you very much indeed for your time. Excellent stuff, thank you. Thank you all for coming, and enjoy the rest of your week. And 3:15, Sensor Fusion and AI is back here with Marinda. Thank you all. Cheers.